A bit of Quartics. Here's our learning goal. I'll recognize and determine the features of the graph, including shape and behavior. Okay, this is what we call a quartic. And we can see here, at least from our learning goal, it's in a pretty straightforward manner. We know this is horizontal shift, and this here is vertical shift. Just before we get into it, again, we'll jump into Desmos. We'll have a look at what happens when we shift around these numbers so we can understand the shape and the behavior of this quartic, and then we'll have a look at how to sketch them. Y equals, let's just start off with 2x minus 1 to the power of 4 for a quartic plus 2. I just want to highlight a few things here. We'll take away this dilation factor for the time being. We know that we normally just start with 0, 0. This is just y equals x to the power of 4 with nothing happening here. We've just written it in vertical and horizontal shift form, but we've shifted 0. We can shift this around here. We know this is a horizontal shift, including those points there. We're going to shift it to the right, okay? Minus goes to the right, plus goes to the left. So we can shift it along. Left, right, we can shift it up, and we can shift it down. If we went minus 1, minus 2, minus 3. Okay, so if I wanted to put it smack on this point right here, which is 4 down, 1 along to the left, my dog, let's go plus 1, minus 4, right? And I get on that spot that I want to get at. Okay, so we can shift this around. We can also have a look at when we dilate it, it gets thinner, very similar to a quadratic. And when it goes negative, it just spins around. So it's like it's similar to a quadratic, okay? And we can have like negative 10, then we can see it gets really skinny. Negative 10, negative 15, negative 150, okay, it gets really thin. So we have a look at, well, how exactly do we sketch these things here, all right? Sketch this, okay, straight away. I noticed that I've got a quartic turning point at the point 3, 1. Okay, because again, it occurs at a point B, C. Right, in our general form, we've got y equals a x minus b plus c to the power of 4. Yeah, it's a quartic. So I've got that quartic turning point there, which is very nice. Now we want to find a y-intercept. We do that, similar process, set x equal to 0. Okay, here we'd have a y-intercept of 163 when you do the arithmetic. And then we need to find an x-intercept. When we do that, we set y equal to 0. So we go right ahead, we do that. Alright, again we solve it, so we take this 1 here over the other side, so negative 1 equals 2, x minus 3, 4, halve it, so we've got a half equals x minus 3 to the power of 4. We take this to the fourth root, negative half equals x minus 3. Then we evaluate, is this possible? No, not possible. And it makes perfect sense that it's not possible because we've got a turning point here, and I know that it goes up like this. Okay, so here's me sketching it. We should also add a tap on the wrist here, Amity. Tap on the wrist. We should have also stated our long-term behaviour. Okay, and so we say, well, we've got A is positive, therefore we've got a minimum value, and as x goes to infinity, y goes to infinity, and as x goes to negative infinity, y goes to negative infinity. Alright, so we need to state that as well. And that's it sketched.